So in this video, we're going to talk about Coulomb's law. So the first thing to be aware of when it comes to charges is that in general, say we have two charges, positive charge and a negative charge, then we know that if we have charges that are opposite, well, opposites attract. So these two charges are going to be attracted to each other, right? And they're going to experience an attractive force. But if we have two charges, let's say they're both negative or they're both positive, then we know that they're going to repel each other, right? So they're going to experience a force that is away from each other. So again, if the charges are the same, then they will repel each other, and if the charges are opposite, then they will be attracted to each other. And how do we know what the force is, what the amount of force is? What is the magnitude of that force? Well, we use an equation called, that is also known as Coulomb's law, and that is force equals K, which is a constant, times Q1, and really we write a lowercase q. So K Q1 Q2 over R squared, and R being the distance between the two charges. So again, the force, F, is equal to constant times charge 1 times charge 2 over R squared. So what do we need to be aware of for the purposes of the MCAT? Well, for the purposes of the MCAT, one of the most important things we should be aware of is this value is R squared. That is to say that the force decreases as the distance increases, but it decreases as the distance increases squared, meaning that distance has an enormous effect on the force, meaning that when two charges are very close, the force is very, very strong. But when the charges get far apart, even a little bit further apart, then the force decreases much faster. And so distance has a huge effect. And so one of the things that we can draw, for example, is we can draw a graph where as the distance increases, what's going to happen to the force? Well, we know the force is going to decrease as the distance increases. So let's say at the beginning we start here. And how fast is it going to increase? Well, it turns out that as the distance increases, force doesn't just do this. It's not linear because it's R squared. The value is R squared. So as the distance increases, force decreases exponentially. So it looks kind of like that. Roughly, it's a little bit, maybe a little less extreme than that. But it's a fairly drastic drop in force. And the interesting thing is, just an aside, this isn't on the MCAT. This won't be tested specifically on the MCAT. Something to be aware of is that this force is the same thing as is essentially the same equation as the gravity equation. So G, which is a constant, m1, m2 over R squared. And so it's kind of an interesting aside. And so that while gravity won't be tested on the MCAT, I do think sometimes it is useful to recognize that it's the same as gravity. We have sometimes we have a bit more of an intuition for the force of gravity than we do for the force of an electrostatic charge. For example, one of the things that we don't realize, but it's true, is that the force between two charges is the same. So each charge is experiencing the same force, or at least the force in the same magnitude. So this is experiencing a force of x newtons, while this is also experiencing a force of x newtons. They're experiencing an attractive force, and the same thing here. The force is the same. What might be different is the weight of the thing. So for example, we have a much larger charge. Let's say we have this charge, then we have this charge, right? And this charge is positive, and this charge is negative. What's going to happen is this thing is going to be attracted to this with the same force that this is going to be attracted to this. However, which one is going to move much further? Well, assuming that this one is much heavier, this one is going to move far less, and that has to do with F equals ma, right? Well, the same force, that means this is going to accelerate much slower. And then the opposite thing here. Although the force is the same, this one is going to accelerate much faster. But the important thing is to realize that it is an attractive force, and both charges are experiencing the same magnitude of force. The force that is on each charge is the same magnitude. And that's all we should be aware of for Coulomb's law for the MCAT.